Mangaru's Tutoring Services Mathematics Classes.
Ascending and descending order. Ascend means to go up and descend means to go down. So when we are talking about arranging numbers or decimals or fractions or a mixture of them in ascending order, it means that we must put the numbers in order from smallest to largest. And placing them in descending order means to put them from largest to smallest. Please feel free to attempt the questions before I work them out. And I will highly recommend that persons learn some of the basic topics such as value and place value, expanded notation, and have a good understanding of what a fraction and a decimal is before doing this topic. So let us begin. Exercise 1. Arrange the following numbers in ascending order. Again, ascending order means smallest to largest. So here we have a ones number, the only ones number. So that will be the smallest number. Then we have 1/10 number. So that will be the second largest number. Then we have 3 numbers in the hundreds. So the 300 is the smallest, followed by 303 and then 330. Number 2. Again, we are putting this in ascending order. We have 5, which is the only ones number. So this will be the smallest number. 55 is the only number that is in the tens. So that will be the second largest number. Then we have 500 and we have 555 in the hundreds. So 500 is obviously less than 555. So 500 will come first, followed by 555. Next we have again only this number in the ones, so we will start with that. Then we have 2 numbers in the tens. So 10 is less than 11, so 10 will come first, followed by 11. Then we have 2 numbers in the hundreds. So 100 will come first, followed by 101. Exercise 2. We are to arrange these numbers in descending order. So descending order means largest to smallest. So here we have some decimal numbers. One thing that we can notice here is that all of them have 0 for the ones number. So in this case, the whole number is insignificant, or we can ignore it since there's no value for it. So we can focus on the decimal fraction. What we can do to make it easier to see the size of these decimal fractions is ensure that all of them have the same decimal places. So identify the ones that have the largest number of decimal places. This one has 2, this one has 2, and this one has 2. This is the only one that has 1 decimal place. So we will add a 0 to the end of it, which doesn't change its value, by the way. 0.2 is has the same value as 0.20. So now we can look at all the digits. So we will look at them like this: 20, 2, 22, and 12. It's much easier to put those in order. So descending again from largest, so 22, but we must write it as it was given, which is 0.22. Then we have 0.2, which in this case looks like 20. Right, so we leave out a 0. Then we have the 12, which is really 0.12. And then we have 2, which is really 0.02. Next, we have 4 digits again. We notice that all of them don't have any value for the whole numbers. So seeing that they have the same value, then we can ignore that 0 for now. So we will focus on the decimal fractions. So again, we're going to make sure that all of them have the same amount of decimal places. So we can see that these two have 2 decimal places. So we're going to ensure that these also have 2 decimal places. So we are going to add a 0 here, and we are going to add a 0 here. So we are going to compare these numbers now: 60, 56, 65, and 50. So 50 is obviously, so no, we are doing descending order. So we go from the largest. So 65 is clearly the biggest number. So we start with 0.65, followed by 60, which is 0.6, followed by 56, which is 0.56, followed by 50, which is 0.5. Next, again we have all of these numbers having no ones value or no whole number value, so we can focus on the decimal fractions. So let us fill in the places with 0 to make all of them have the same number of decimal places. Okay, so descending order again from largest to smallest. So 80 is the biggest. So that's 0.8, followed by 58, which is 0.58. Then we have 50, which is 0.5. Then we have 8, which is 0.08. And then we have 0.05. So lastly, for the decimal questions, arrange these in ascending order. So now we have different whole numbers, or we have different values for the ones digit. So we can see we have 9 here, so that's 9 ones, 7 ones, and the rest of them is 0 ones. So we know that we will start, for ascending order, smallest to largest, we will start with these 3 numbers, because they have 0 for the 1, so it will be smaller than the other 2. So again, we're going to ensure that all of them have the same number of decimal places. So we just need to ask ourselves which is the smallest of this, this, and this. So 70 is smaller than 90, and 90 is smaller than 97. So 0.7 followed by 0.9 followed by 0.97. So then we have the last 2 digits. So 7 is clearly less than 9. So the 7 will be the next digit, or rather the 7.9, then the 9.7. Next, again, we are arranging these in ascending order. So if we look at the whole numbers, we can see that the 0 is the smallest. Then we have 2 numbers having 1. Then we have the last one having 10. So this will be the smallest, then one of these, then afterwards this would be the largest. So seeing that these two have the same ones number, we are going to fill in the decimal place here so that we can easily compare the 0.06 to the 0.6. So we know that 6 is less than 60, so it will be 1.06 followed by 1.6. Number 3. So here we have 1, 2, 3, 4, 5, 6 numbers. All of them have whole numbers. So we will extract the ones that have 3 as the whole number first. So 3 here, 3 here, and 3 here. So we know that these will be smaller than the ones with the 4 as the whole number. Secondly, let's fill in all the missing decimal places, which is only right here. I missed this one. Right. So we have 4 numbers that begin with 3 and 2 numbers that begin with 4. So seeing that all of the 4 begins with 3, we can just compare the decimal numbers. So we are comparing the 44, the 43, the 34, and the 40. So 34 is the smallest. So we have 3.34 followed by 3.4 followed by 3.43 followed by 3.44. So now we just have the last two numbers, 4.34 and 4.03. So since both of them have 4, we are just comparing the 3 with the 34. We know that 3 is less than 34. So that's 4.03 comes before 4.34. Before you begin this exercise, I highly recommend that you learn fractions, subtopics such as equivalent fractions, adding and subtracting fractions, mixed numbers and improper fractions, multiples and factors. So again, a reminder, persons can attempt the questions before I work out the solution. Let's begin. Exercise 4, number 1. So for these questions, there are more than one ways that we can work them out. So I will try to show you the two methods that is commonly used. So the first method involves finding the LCM, the lowest common multiple. So the lowest common multiple of 4, 2 and 3 is simply the smallest number that 4, 2 and 3 can go into without a remainder. Or in other words, what number can be divided by 4, 2 and 3 and not give a remainder? So that number is 12. So knowing your tables will help with this. So essentially what we are doing is making a quarter into an equivalent fraction where the denominator is 12. We are doing the same thing for the half, making the half into an equivalent fraction where the denominator is 12, and also we are making a third into an equivalent fraction where the denominator is 12. We are not changing the value of any of the fractions. We are making them to have the same denominator so we can compare them easily. So 4 into 12 is 3. 1 times 3 is 3. Put back the comma. 2 into 12 is 6. 1 times 6 is 6. 3 into 12 is 4. 1 times 4 is 4. Now we can easily see which is the smallest number, the next largest, and the largest. So let's put them in ascending order. I will now show you another method. So the other method involves making all of these into equivalent fractions. So again, we need to think and determine what number we can multiply each fraction by, which it can be a different number, it would be a different number, to make all of them have the same denominator. So we can say 4 times 3. So if we multiply the denominator by 3, we must multiply the numerator by 3. We know that will give us 3. 1 times 3 is 3. And 4 times 3 is 12. Then we want all of them to have the same denominator. So we know 2 times 6 is 12. So we must multiply the numerator by the same number. So 1 times 6 is 6. And 2 times 6 is 12. And lastly, we know that if we are trying to get 12, then 3 times 4 is 12. And we must multiply the 1 by 4. So 1 times 4 is 4 over 3 times 4 is 12, which is the same fractions we got in the previous method, and then we can compare them and we'll get the same answer. Number 2. So seeing that we worked both methods above, we will continue to work with the LCM method. In my view, it's easier for this type of question. So let us continue. We will find the LCM, lowest common multiple. So what number can 3, 4, and 6 go into without a remainder? So it's actually the same number as the previous question, which is 12. 3 into 12 is 4. 4 times 2 is 8. 4 into 12 is 3. 3 times 3 is 9. 6 into 12 is 2. 2 times 5 is 10. So this happened to be in ascending order already. Number 3. So again, we are going in ascending order. So we must determine which number can 5, 4, 10, and 20 go into without a remainder. So all of them can go into 20 without a remainder. 5 into 20 is 4. 4 times 2 is 8. 4 into 20 is 5. 1 times 5 is 5. 10 into 20 is 2. 2 times 3 is 6. 20 into 20 is 1. 1 times 7 is 7. So here we can see the order: first, second, third, and fourth. Exercise 5. Arrange the following fractions in descending order. So again, we will continue to use the LCM method. Fortunately, for this question, number 1, all of them have the same whole number, which is 2. So we can simply just focus on the fraction and put those in descending order. So what number can 5, 3, and 15 go into without a remainder? What is the lowest number? That will be 15. So we will put the 2 outside here, which represents 2 for all of them. 5 into 15, or 15 divided by 5 is 3. 3 times 1 is 3. 15 divided by 3 is 5, and 1 times 5 is 5. 15 divided by 15 is 1. 1 times 4 is 4. So descending order, largest to smallest. So this will be the first, then this, then this. Number 2. So these fractions here are improper fractions. We have 2 ways we can work this. We can either convert them to mixed numbers and then put them in ascending order, or we can leave them as improper fractions. Sometimes it works out better to convert them to mixed numbers. Sometimes it's better if we leave them. When the numerators are large, I like to make them into mixed numbers, so that way we don't have to multiply huge numbers. In this case, the numbers are not very large, and I also know that the LCM would not be very large. So what number can 2, 6, and 3 go into? All of them can go into 6. So we are going to leave them as improper fractions. 2 into 6 is 3. 3 times 7 is 21. 6 divided by 6 is 1. 1 times 20 is 20. 6 divided by 3 is 2. 2 times 11 is 22. So the largest number is 11 over 3. Then 7 over 2. Then 20 over 6. So that wasn't too difficult. Number 3. We have a mixture of mixed numbers and improper fractions. What I prefer to do for this type of question is make all of them into mixed numbers. Now you can also make all of them into improper fractions, and sometimes that might be easier. So we're going to make the 5 over 4 into a mixed number. 4 into 5 is 1, remainder 1, and we put that over the same denominator. 3 over 2, 3 divided by 2 is 1, remainder 1, put back the same denominator. So we will just cancel this for now so that we don't get mixed up. So what is the, so before we go on, we can see that all of them have the same whole number. Which is 1. So we can simply just compare the fractions. So 3/8, 1/4, 5/16 and a half. What number can 8, 4, 16 and 2 go into without a remainder? That would be 16. So 8 into 16 is 2. 2 times 3 is 6. 4 into 16 is 4. 4 times 1 is 4. 16 into 16 is 1. 1 times 5 is 5. 16 divided by 2 is 8, and 1 times 8 is 8. So this will be the largest, followed by this, then this, then this. So we must put back the original fractions that they gave us. So notice I put back the 3/2, not the 1.5.
Thank you for watching. If you have found this video to be helpful, please feel free to contact us for more information about our classes.